Have you ever wanted to make an electrical circuit, use batteries, LEDs, wires, stuff like that, but you didn't know how to get started? Well, TinkerCad is a tool that allows you to learn all of that stuff, but without getting your hands too dirty, without having to solder, without having to actually own any of the parts. And it's really simple and easy to use. And in this video, I'm going to show you how to connect a battery to an LED and make it light up, similar to this. So this is ultimately what we're going to be doing in this video. We have a battery, we have some wires and stuff like that, and we are going to turn this light on and off, on and off. So we're going to make something exactly like this. And it's going to be really easy and simple, and I'm going to show you every single thing that we're doing step by step so that you can start creating your very own electronics for free today. We also have a blog post on our website, blogs.baruch.cuny.edu/makerhub, that details everything that we're going to do in this video, along with an infographic that shows you some of the most commonly used components in TinkerCad. So this is going to be a lot of fun, so let's just get right to it. Alright, so the very first thing that I want to do is go to the home page. And at the home page, you'll find a couple of things on the left side panel. You'll see 3D design, circuits, code, lessons. We're going to want to be in circuits, obviously. We're going to click create new circuit. Great, so what we have here is our workspace. So anything we drop over here is what we're going to be able to work with. So the first thing that I want to do is really grab a power source. So in this instance, I like to grab a 9-volt battery, but you could grab different type of batteries. You just kind of bring them along. I encourage trying to experiment what happens with different things if you try different things, but for this instance I like to use a 9-volt battery just because it's got that Duracell look and it just looks very battery-ish. So with that done, let's go ahead. I'm actually also gonna flip these around, so you can click this button and turn these around in different directions and orientations. So I'm gonna leave my battery just like that. What do we need next? Obviously we're gonna need a LED if that's what we're trying to light up, right? An LED. And really, that's all we need if we're supposed to be lighting up an LED, right? So a power source and an LED. So let's go ahead and connect those things. One note, I do want to flip this guy over. So the long leg of the LED, or the bent leg, is the anode, and that is the positive terminal. You connect this to the positive side. And the cathode is the negative terminal. You connect this to the negative side of your battery. Actually, I'll flip this horizontally like so that I can have this guy coming over here very nice and neatly, and the same with this one. And we could grab these wires and move them around just a little bit. You could even go here and click. You know, do something like that if you really wanted to. But you know what? Why don't we just leave it like that? So what we're doing, we can also change the color of these wires. So that's exactly what I'm going to do now. You can change it all these different colors, or you can click on the wire and click on a number on your keyboard and it'll change it accordingly. Best practice for electronics, just the rule of thumb, is you want your positive terminal, where your energy is coming from, essentially, to be red, and you want the negative to be black, or where it's you know, just the negative terminal, whatever's connected to the negative terminal. That way it makes things a lot easier to see, and it makes you understand the flow of electricity a little bit easier. So let's go ahead and start the simulation. So what happens if we start the simulation? Whoa, what is this? Too much current, it exploded. So what did we learn here? We need to somehow limit the amount of electricity that's running to this LED. So let's go ahead and do that by using a resistor, something like this. And what we can do with the resistor is it's going to take the amount of electricity and it's going to turn it down. It's going to turn down the current. So we're going to delete this wire and connect this guy over here. Remember, I'll click the number 2 so I can make it red, and then I'll connect this guy here and make this red. Now it doesn't matter which side you connect your actual your resistor. Fortunately it doesn't matter, so you could have it this way or the other way. It doesn't actually matter. So now let's see what happens if we turn on this LED. Look at that, and I shouldn't say turn on. Just connect or close the circuit. Really, is what I mean. So because there's no start button or stop button here, we're just saying, all right, let's see what happens if this was connected appropriately right now. Later, in a second, we're going to be adding that on and off button. But you can see what's happening is that the electricity is going from here, going into the resistor, and then it's dropping a little bit, and then it's going a little safer into the LED. Now, we can change the values of the resistors very easily right here, actually. It's in K ohms, so that's kiloohms. That's what the value is called, an ohm. And what we can do here is, you see it's 1. Why don't we make it 10? It gets real dark, the LED, right? Why don't we make it 100? It pretty much turns off, right? Because there's you're limiting the electricity going in. So why don't we bring it down to back to 1? What happens if I do 0.1? Whoa, look at that. It looks like we're getting a warning that, hey, this might be too much. It didn't pop yet, but maybe the LED in the long term is not going to be able to sustain this kind of power going into it. So let's find a nice bright spot, but it's still safe. So 0.2, nope. 0.3, nope. 0.4, 0.4. So it seems like 0.4 is the safest we can get before this pops. So I'm going to keep it just like that. You'll also notice that the colors change. This is a way to identify how the actual value. If you look at the LED right now, you see it changing, like colors. And that's because it's changing the value, and it's an easy way for you to see the value of the resistor. I think I said look at the LED. I meant to say look at the resistor for the color values. Anyway, let's go back to 0.4 because that was our safe spot. And that's good and dandy, but there's no way to start or stop this circuit. It's just going to run perpetually all the time. We don't want that. So why don't we... Well, the circuit automatically stops if we grab something here, so that's good. And we're going to grab a slider switch. You can also grab other switches, other things like a push button, very similar. The point of these interfaces is that you're acting on it, you're doing something. So in this case, I'm flicking a switch here, or in this case, I would be pushing a button. But ultimately, the purpose is to close the circuit so that the energy goes in a full circle, a perpetual circle of electricity. So let's get rid of that, and let's get rid of this guy. And you know what we're gonna do is actually I'll take this guy out too. We're gonna put our positive terminal to our middle terminal of our slider switch, and then we're gonna connect this to our resistor. So now we have electricity going from here to here, and then from here to here. Notice that this is not connected. You don't need to connect this one. The purpose really is for this to not be used. We want this to close the circuit. So when we click on this, it'll connect this side and this side together. Right now, it's empty, so it's not closed. But either way, we're gonna go from here to here. And now, what do you think is going to happen if we start the simulation? If you thought the light would turn on, you would be mistaken. Why would you be mistaken? It's because the circuit's not closed. It's still open. Now we're going to close it. And the light turns on. Amazing. So that's basically how you connect an LED to a battery and make it light up. Very simple. However, this is really clunky, isn't it? I mean, think about it. If you have to transport this, you have to move it around. It's not going to be very fun. You also have to solder this stuff. So you need to mess with soldering iron, and you have to start messing with heat, and it can get dangerous even. So what is a simpler way to connect these things without soldering and make it just a little elegant and not clunky? That's where the breadboard comes in. So this is a breadboard, and the purpose of a breadboard is just to allow you to connect electronics, but you don't need to solder anything. You can just plug in the little your pins, your terminals right in these holes, and then they'll connect to other pins and terminals that are connected into the same rails in these rails. So why don't we go ahead and do that now? To do that, I'm going to grab all of these guys and delete the wires, so I just have my components, so I can rewire everything. And excuse me. So I have here my 9-volt battery. What I'm gonna do is I'm gonna flip this battery a little bit, because just so I can have this red coming to the red and the black terminal. Whoop. There, positive to positive and negative to negative. Just a little neater, just so I'm not doing too many loops and hoops and jumping over anything too much. See? So it's a little simpler and neater if I just do that as opposed to having it all flipped around, right? So let's go back there. All right. So now what we need to do is grab our resistor. Okay, great. So now what is happening here? everything that's on, green right now is going to be powered because this entire rail is interconnected. So if I do this and this, whoops, if I do this and this whole rail here is also getting power because this is connected and then this is connected to this one. See? So I hope that helps illustrate how the power transfer happens on a breadboard. The rails are connected to other rails. So let's undo that and bring our resistor in. Now, we want to connect, let's see, some electricity. Let's bring some electricity up from here to just there. And let's bring our resistor and bring them from here to here. Now let's turn this guy around just a little bit for neatness. There. All right, so I hope you can see what's happening here. Electricity is going in here under there's a metallic wires under, and then it's connected to this guy, and then underneath it's connected to this guy, and there we go. So we can take our other components and connect them over here. I actually like to do the slide switch before the other components, so I'm gonna move this guy over. I'm gonna bring the slide switch here, and then from here I'll connect it like so. Okay. Now, I just want to illustrate again, these are not touching. These two are not touching. The vertical rails are touching, but the horizontal ones are not touching each other. So this whole thing is not touching this one, but this one is touching this one, and this one is touching this one. You know what? Maybe just to illustrate that a little better, I'll make it clearer. Break these up right there. All right, great. And now what we have is our LED. I can place that right there, or I can even do something like this. Maybe that helps illustrate the flow a little bit better. So it's coming in here, and here, and here, and here, and here. And now we have to connect this to our negative terminal. And now we have a closed circuit. So let's take a look at what's happening here. So if we turn this on, we're getting positive energy from here, and then it's coming from here, going over there, and then it's currently closed, so it would continue, light up our LED at the appropriate value, and then to the negative, and then from the negative, it'll just cycle all over again. So what should happen when we turn this on? If you say it should just turn on automatically because this is a closed circuit, you would be correct. Amazing. So that is how we turn on an LED, a basic LED with some basic components. This is really simple stuff, and it's something that you can have a lot of fun with. Look at all these items that you could use. So all these components are totally free. Obviously, they're they don't exist. You can just use as many of them as you want. But there's so much to learn in TinkerCad, and it's a really fun tool, and it's a free tool, and I very much encourage you to poke around and look at all the components that they have. If you'd like to learn more about electronics just like this, you can take a look at the blog post that we have that covers exactly what we went through, along with kind of a cheat sheet, an infographic of the most commonly used TinkerCad components. You can also go to our website and just learn all the stuff that we have to offer. This is some of the stuff that the Maker Hub actually does all of the time. We actually, we are a resource for students to learn about electronics, 3D modeling, all kinds of stuff like that. So if that's something that you're interested, please go to our website, and we hope to see you there. That's all for me. Take care.